Good morning, dear. Today we will continue correcting our midterm exam. Number 11. ABC is a triangle that has AB equal to AC and BAC is 90 degrees. Then the triangle ABC is it a right isosceles at A, at B, or semi-equilateral triangle? To discuss them, a semi-equilateral triangle is a triangle that has three angles, 30 degrees, 60 degrees, and 90 degrees. Here we have given only one of these angles. The right isosceles triangle is a right. It has a 90 degree, it has a right angle, and isosceles, so it has two equal sides and two equal angles. Since BAC equal 90, then ABC is a right triangle. And since it has two equal sides, AB equal to AC, so it's an isosceles triangle. So it's a right isosceles triangle, but at A or at B, which one of these options is correct? Let's look together. AB equal to AC. So A is a common vertex. It's the main vertex of isosceles triangle since it um, holds the two sides that are equal. So it's a right isosceles triangle at A. Justification: since triangle ABC has two equal sides and it's right at A, then it's a right isosceles triangle at A. In the following orthonormal system, the correct statements are: we have 5 statements, 3 of them are correct. Let's look first at the figure. We have A, I, C, B. These are the points plotted on the system. To calculate AI, let's check first. Is IA equal to IC? It's obvious from the figure, but I have to do calculation to get sure. AI, how to find the distance AI? It's the big abscissa minus small abscissa. So it's XA minus XI. 3 minus 1 is 2. So AI equal to unit of length. What about IC? It's XI, which is 1, minus X, let's see, minus 1. So 1 minus minus 1, it's the same as 1 plus 1, which is 2. Since AI equal to CI equal to 2 centimeter or unit of length, then I can say that the first statement is correct. What about AC? Is it 3 centimeter? AB 4? I can check them from the figure and I can make calculation. Look, AC. If we say that each one of these boxes represent 1 centimeter, then AC is 1, 2, 3, 4 centimeters. Okay, or by calculation, I can say it's big abscissa minus small abscissa. So 3 minus minus 1 is a 3 plus 1, which is 4. So AC is not 3. What about AB? 1, 2, 3. AB equals 3 centimeter, not 4 centimeter. Or by calculation, I can say it's big ordinate minus small ordinate. So 1 minus minus 2 equal 1 plus 2 equal 3. Let's check the others. AB perpendicular to AC at A and BI is a median relative to AC. Here, we said that AI equal to IC proved in the first part. So clearly I is the midpoint of AC. And in the triangle ABC, BI is a segment issued from the vertex to the midpoint of the opposite side. So clearly BI is a median relative to AC. As a definition, a median is a segment issued from the vertex to the midpoint of the opposite side. And this is the case of BI. So it's a median relative to AC. Now, can I say that AB perpendicular to AC at A, the last option here? to choose or not to choose. Let's see. We have that AB is parallel to y prime y. Why? Because they have the same abscissa. So the line formed by them is parallel to the y prime y. What about AC? They have the same ordinate, which is 1. So the line formed by A and C is AC. It's parallel to x prime axis. And since y prime y perpendicular to x prime x, and here AC parallel to x-axis and AB parallel to y-axis, and these axes are perpendicular to each other, then yes, AB perpendicular to AC at A. And this statement here is correct. Now, in an obtuse triangle, it has an angle greater than 90 degrees. The point of intersection of all heights, so we are talking about orthocenter. The intersection of height is inside the triangle in all cases. Look with me at this figure. Here we have ABC is an obtuse triangle since ABC is an obtuse angle here. This is the first height, BE. We have AF, a height relative to BC. And CD is the third height. These three heights intersect at point O, which is orthocenter. And this orthocenter is outside the triangle. So this expression is false, it's not true. In an acute triangle, the point of intersection is inside the triangle, while in an obtuse triangle, the point of intersection is outside the triangle. Now, UVW is a triangle that has UV equal to UW. UV equal to UW. So it's an isosceles triangle with vertex U. UWV equal to 60 degree. Isosceles triangle with 60-degree angle, then the triangle UVW is an equilateral triangle. It's not right. Why? Since it has a 60 degree. We have here, since triangle UVW has two equal sides and an angle of 60 degree, directly I can conclude that it's an equilateral triangle, applying the rule that I can prove a triangle equilateral if it's an isosceles triangle with an angle 60 degrees. So this is our correct answer. Number 15, calculate. Showing all the steps of calculation, you have to show me how did you solve. So if you put just the final answer, you will not get the full mark. B equal minus 10 plus parenthesis plus another parenthesis. Keep in your mind, according to PEMDAS rules, I have to start by parenthesis, multiplication and division, addition and subtraction. Here we have parentheses. I can start solving what's inside them. Inside this parenthesis, we have division and addition, so priority goes to division. On the line, I should write minus 10 plus 6 divided by 3 is 2, and its sign is negative, plus 5, plus in this parenthesis here we have multiplication and addition, so priority goes to multiplication. 2 times 9 is 18, and 8 times 2 is 16, and we should not forget to write the sign that's in front of 2. Okay, now let's solve what's inside the parentheses. 5 minus 2 is 3, and 18 minus 16 is 2. So minus 18 plus 16 is minus 2. And of course, we have to drop minus 10 at the beginning. Now let's get rid of the sign. Minus 10, I should write it. Plus 3, it's plus 3. Plus minus 2, minus 2. So minus 10 minus 2 is minus 12. And minus 12 plus 3 is minus 9. The last part, In an orthonormal system, given the points A, B, C, D, E, and F, here I plotted them on the system, we conclude that I have to choose the three correct answers. Let's start. Points B and F. B is 4, 2 and F minus 2, 2. They have the same ordinate, the same y, which is 2. Okay, so I can say that BF is parallel to x-axis. We can see it from the figure. BF here is parallel to x-axis. Okay, what about E and D? They have the same ordinate. D is 4 minus 2, E minus 3 minus 2. These are the coordinates. The first number corresponds to abscissa, while the second one to the ordinate. Here we have minus 2 and minus 2. They have the same ordinate. Then D and E is also parallel to x prime x. Both lines are parallel to the same third line, which is the x-axis, so I can say that they are parallel to each other. Then FB is parallel to ED. Okay, the first option, AD parallel to BC, this is AD and this is BC. Are they parallel? No, they are intersecting, though, so the first one is not correct. Next one. B is in the second quadrant. B here is point B. It's in the first quadrant, not in the second. Now, AC parallel to BD. AC and BD. To be parallel, they are obviously that they are parallel to the y-axis. So let's check their abscisses. A and C, A1 and 2, C1 minus 2, they have the same abscissa, which is 1, so they are parallel to y prime, y. What about B and D? B4, 2 and D4 minus 2, B and D also have the same abscissa, so BD is parallel to y axis. AC and BD, both lines are parallel to the same line, which is y-axis, so definitely they are parallel to each other, and this choice is correct. AC is parallel to BD. Now E is in the third quadrant. Let's look. Here is the first quadrant, second quadrant, and third quadrant. E is here. The third quadrant has negative abscissa and negative ordinate. Okay, we can check it from the coordinates, minus 3, minus 2, they are both negative, or from the figure, they are both correct. Thank you for your attention.